Okay, let's unpack this. It is February 5th, 2026. And if you have been online at all this week, you know the vibe shift is palpable.
Oh, it's more than palpable.
The AI news cycle isn't just fast right now, it feels violent. We are watching what I think historians will probably look back on as the agentic arms race.
Arms race is the only way to describe it. I mean,
Okay.
we are seeing a level of acceleration that makes the 2023-2024 boom look like a calm warm-up.
Exactly.
It's no longer just about who has the smartest chatbot. It's about who controls the entire development environment.
Right, it's a battle for the keyboard. And just looking at the headlines from the last, 72 hours, you can see two very distinct camps forming.
Mm-hmm.
On one side, you have the cloud titans just flexing their massive proprietary muscles. Anthropic drops Claude Opus 4.6.
The 1 million token context, the agent teams.
Then OpenAI immediately fires back with GPT 5.3 codex and that, dedicated desktop command center.
Or Apple is basically the kingmaker there. Integrating both of those behemoths directly into Xcode 26.3 was a massive, massive power move.
Yeah, if you're an enterprise dev in the Apple ecosystem, you just got the two smartest entities on the planet living inside your IDE.
Exactly.
But then you have this other camp, the rebels, maybe? The local faction.
I like it.
You've got Mistral in Paris releasing Voxtral Transcribe 2 for total on-device privacy.
Yep.
You have Moonshot in China dropping Kimi K2.5, which is this huge open-weight beast.
It is a very crowded room.
Yeah.
But amidst all of that noise, the Super Bowl ads, the CEO feuds on Twitter, there was a release on February 3rd that I think is arguably more important than all of them.
From the Qwen team at Alibaba.
Exactly. Qwen3-Coder-Next.
And this is exactly why I wanted to do this deep dive today, because while OpenAI and Anthropic are fighting over who has the biggest, most expensive brain in the cloud, Qwen seems to be flipping the entire board over.
They're not playing the bigger is better game anymore.
Not at all.
No, they're playing smarter is faster. And maybe more importantly, smarter is cheaper. This release, it challenges the fundamental economics of how we build software with AI.
Okay, so we're looking at a model that has the reasoning of a giant, but runs with the speed of a sprinter.
That's the promise.
So the mission for this deep dive is to look past all the marketing hype from the US giants and really dismantle the architecture of this Qwen3-Coder-Next. We need to talk about vibe coding, this new agentic training pipeline, and why this specific model might actually signal the end of the mammoth model era.
It feels like a pivot point.
Okay.
We are moving from models that just read code to models that live inside the code.
So let's start there with the context. Vibe coding. We see the term everywhere. It's basically become the default workflow for a lot of developers, right? You just describe the functionality, the vibe of the app.
And you just expect the AI to handle all the implementation details.
But from a hardware perspective, that kind of coding is a complete nightmare, isn't it?
It's a massive resource hog. I mean, when you're vibe coding, you aren't just asking a question and getting one answer. You are in a continuous loop. You generate code, you run it, you hit an error, you paste the error back in, you iterate, you iterate, you iterate.
So latency is the enemy. If I have to wait 30 seconds for my vibe to execute, my flow state is just, it's broken.
Completely broken. Throughput, how many tokens per second the model can generate, is the single most important metric for an agent. And this is the paradox that Qwen3-Coder-Next is trying to solve.
How so?
Well, on paper, it's an 80 billion parameter model. In the old world, an 80B model would be slow, heavy, and incredibly expensive to run.
Right. 80 billion usually means you need a serious GPU cluster to get any kind of decent speed.
Right.
But they claim this thing flies.
And that's because it's not really an 80 billion parameter model, at least not all at once. It uses a mixture of experts and MoE architecture.
MoE, right?
So think of it like a massive law firm. The firm has 80 specialized lawyers on staff. Those are your 80 billion parameters. But when you walk in with a specific tax question, you don't meet with all 80 of them.
No, I just meet with the tax guy.
You meet with the tax guy and maybe, with a compliance officer. In Qwen's case, for every single token it generates, it only activates about 3 billion of its parameters.
That is a massive reduction. So you have the knowledge base of the 80 billion parameter giant, but the actual compute cost is closer to a tiny 3 billion parameter model.
And that 3 billion number is the sweet spot. That's small enough to run at incredible speeds, even on consumer hardware or, like, edge devices. We are talking about 10x higher throughput compared to a dense model of the same total size.
Which fundamentally changes that vibe coding loop.
Completely.
If the model is 10 times faster, I can iterate 10 times in the same amount of time it takes GPT-5 to give me one answer.
And that is where the agentic capability comes from. An agent has to think fast. If it takes a minute to verify a line of code, it's useless. If it takes a second, it's a superpower.
Plus, you've got the license, Apache 2.0.
Which is the other shoe dropping, right? OpenAI and Anthropic, they're closed loops. You're renting their intelligence. Qwen is just giving this away.
So enterprises, startups, indie hackers.
Anyone. They can take this 80B3B hybrid, they can fine-tune it on their own proprietary data and run it locally without sending a single packet of data to a cloud API.
It effectively commoditizes that junior engineer tier of AI. But okay, speed is one bottleneck. The other one, the one I struggle with constantly, is context. The memory wall.
The bane of all large language models.
Right. We all know the pain of traditional transformers, that quadratic scaling. You double the length of the document you want the AI to read, and the computational cost doesn't just double, it quadruples. It makes reading an entire codebase financially impossible for most local setups.
It's a physical constraint of the attention mechanism. The model has to pay attention to every single word interacting with every other word. Qwen3-Coder-Next tackles this by hybridizing its architecture. They're using something called gated delta-net alongside gated attention.
Okay, gated delta-net. I've read the paper, but break that down for us. How is this different from the standard transformer attention we're all used to?
So think of a standard transformer, like a court stenographer. It writes down every single word spoken in a trial. If you ask a question about what happened on day one, it has to go back and read the entire transcript.
And as the trial gets longer, that transcript gets impossible to manage.
And searching through it takes forever.
Correct.
DeltaNet operates more like a judge taking notes. Instead of keeping that raw transcript, it maintains a state, sort of a running summary of the trial.
Ah, I see.
When a new piece of evidence comes in, it just updates the state. It compresses the history into a fixed-size memory.
So it doesn't need to look back at the raw history because the state already contains the relevant context.
In theory, yes. This gives it linear complexity. You can just keep feeding it data, and the memory usage doesn't explode. It's what allows Qwen to support a context window of 262,144 tokens.
That is enormous. I mean, that's enough to fit the entire documentation of a new framework, plus its source code, plus your messy legacy project, all in one prompt.
And because of that DeltaNet efficiency, it can process that massive dump of data without slowing to a crawl. It can read an entire Python library and then answer questions about it with the latency of a short conversation.
But there's always a catch with these long context models, right? We've seen it with Gemini and others, the lost in the middle problem. You feed it a book and it forgets what happened in chapter 12.
Right, the hallucination problem.
How does Qwen make sure it's actually understanding the structure of all that data?
So they implemented a training strategy called Best Fit Packing, or BFP. It addresses a specific issue in how we teach these models. Usually, to train on long context, engineers just glue a bunch of documents together, end-to-end, to fill up the buffer.
Like a giant run-on sentence that just spans different topics.
Exactly, and that confuses the model. It causes these truncation errors. It doesn't know where one idea ends and the next one begins. BFP is an algorithm that organizes the training data, the length and distribution of the document to minimize those cutoffs. It ensures the model learns the structural integrity of a file or a module.
So it respects the boundaries of the code. It knows that filia.py is distinct from phylib.chi, even if they are fed in continuously.
Which is critical when you're dealing with code, where scope and syntax are everything. But, architecture is only the skeleton. The muscle, the actual coding ability, comes from the training data.
And this is where that agentic arms race really shows its hand.
Yes.
This was the part of the report that just jumped out at me. We are moving from read-only training to agent-first training. For years, we taught models by showing them code and just saying, predict the next word.
Which is like teaching someone to be a carpenter by having them read books about wood. They might know the theory, but give them a hammer and they won't know how to drive a nail.
Right.
Qwen3-Coder-Next was trained using an agentic pipeline orchestrated by Alibaba's Megaflow system.
So instead of just reading code, it was actually writing and fixing code during its training.
Exactly. They generated 800,000 verifiable coding tasks. And these weren't synthetic Hello World examples. These were real-world bug fixes mined from GitHub pull requests. And they created this closed loop.
Okay, walk us through that loop. What happens when the model tries to fix a bug?
So imagine the model is given a task. Fix the memory leak in this C++ function. The model generates a solution. In a traditional training run, that's the end of it.
But not here.
But here, Megaflow actually spins up a container, a Docker environment, and compiles the code.
It runs the code for real.
And it runs it. And let's say the code compiles but fails a unit test. Or maybe it causes a segmentation fault and just crashes the container. The model receives that error log, that specific feedback from the environment.
So it actually sees the consequence of its own action.
Yes, it gets the stored output. Then it attempts to fix its own mistake. It thinks, oh, I forgot to free that pointer. It rewrites the code, runs it again, if it passes.
That whole interaction becomes the training data.
That entire interaction, the mistake, the correction, the success, that becomes the training data.
That is a profound shift. It's learning causality. It's learning, if I do X, the compiler yells at me. If I do Y, the test passes.
It is reinforcement learning from compiler feedback. It bridges the gap between syntax and logic. And they didn't stop at single files. Mid-training, they fed it 600 billion tokens of repository-level data.
To handle the cross-file dependencies, because in the real world, if I change a variable in my config file, it breaks the API handler in a totally different folder.
Exactly. If you only train on single files, the model is blind to those dependencies. Qwen learns the graph of a repository. It understands that changing utils.py has ripple effects.
And looking at the specs, this training clearly paid off in versatility. It supports 370 programming languages now.
Up from 92. And that's not just vanity metrics. That includes legacy languages, obscure scripting dialects, configuration formats. It makes it a truly universal tool.
Speaking of formats, I noticed a small but really interesting detail about how it talks. They ditched JSON for tool calling.
Oh, this is a huge quality of life improvement for agents. We've all struggled with JSON-based agents. You ask it to write a Python script inside a JSON object, and it forgets to escape a quote, and the whole parser just explodes.
The invalid JSON error loop, it's the worst.
So Qwen introduced an XML-style format called Qwen3-Coder. It's designed specifically for passing long strings and code blocks without all that overhead of escaping characters. It's just a cleaner, more robust protocol for the agent to communicate with its environment.
That's smart. They optimized the communication layer for the machine, not just the human, but they went even deeper on specialization. They didn't just trust this one general training loop. They built specific expert models and then distilled them back in.
Correct. I mean, even with agentic training, a general model might struggle with very specific, nuanced tasks, like pixel-perfect CSS or complex build tool chains. So they trained a web development expert.
And this wasn't just text-based either, was it?
No. They used a vision language model, a VLM, in the training loop. When the web expert built a web page, they would render it in a headless Chromium browser and have the VLM actually look at the screenshot.
So the AI is judging the visual output, like, is this div centered? Is the contract correct?
Yes. It's verifying the visual layout integrity. A text-only model can write perfectly valid HTML that looks terrible. This expert learned to write HTML that looks right.
And then there was the UX expert for tool use.
Yeah, that one focused on scaffolds like Klein or OpenCode. It was trained on these diverse chat templates just to make sure it doesn't get confused when the user switches tools or schemas.
And then, and this is the distillation part, they took the lessons from both the web expert and the UX expert and crammed all that knowledge back into the main 80B3B model.
Think of it like a master craftsman teaching an apprentice. The massive specialist models generate thousands of these reasoning traces, these step-by-step guides on how they solved a problem. The smaller, faster model then trains on those traces.
So it learns to mimic the thought process of the expert without needing the massive brain to do it.
Exactly. The deployed model is the apprentice that has memorized the master's moves.
Which brings us to the results. Does this fancy architecture and this agentic loop actually translate to better code?
Well, the benchmarks say yes.
Okay, let's look at SW Bench Verified. This is the gold standard for can you fix a real GitHub issue.
Qwen3-Coder-Next hit 70.6%. And to put that in perspective, DeepSeek v3.2 is at 70.2%. So it just edged out a major competitor.
And it's slightly behind GLM 4.7, which is at 74.2%. But we have to remember the efficiency delta. Qwen is achieving this with only 3 billion active parameters.
It's punching way, way above its weight class.
But the number that really stood out to me was on Qwen Bench, the security one.
This is critical. I mean, if we are moving toward these agentic workflows where the AI has write access to our repos, security is completely non-negotiable.
You don't want an agent accidentally introducing a SQL injection because it was vibing too hard.
Or hallucinating a dependency that doesn't exist. On the Qwen bench, which measures the ability to repair vulnerabilities, Qwen scored 61.2%. That significantly outperforms Claude Opus 4.5, which scored 52.5%.
Wait, it beat Claude Opus. That is a very expensive, very smart model.
It beat it, and the most impressive part, it did it without any security hints.
Meaning the prompt didn't say, hey, fix the security hole.
Right, it just saw the code and recognized the vulnerability implicitly. And that goes back to the agentic training. It likely encountered similar vulnerabilities during those 800,000 tasks. Maybe it wrote insecure code, the container got hacked or failed a security test, and it learned from it.
It developed a kind of security instinct.
That is massive for enterprise adoption. You can trust this little 3 billion parameter agent to not leave the back door open. And it also outperformed the others on multilingual security on CW Evil. So it's finding bugs in Python, Java, C++, all across the board.
So let's bring it all back to the arms race we started with. We have the cloud giants doubling down on size and integration. And now we have Qwen proving that you can get elite performance with a fraction of the compute if you just change the architecture. What does this mean for you, the listener?
It means the barrier to entry for agentic AI has completely collapsed. I mean, until now, if you wanted a top-tier coding agent, you had to pay a monthly subscription to a U.S. tech giant and send them all your IP.
Now you can just pull Qwen3-Coder-Next from Hugging Face, load it onto a decent laptop or a local server, and have a senior engineer-level agent working for you, basically for free.
It empowers the local AI movement. It challenges the idea that intelligence is a service you must rent. It validates that intelligence can be a product that you own.
It feels like it splits the market. You have the Cloud Brains, Moonshot, GPT-5 Claude, which are great for massive heavy lifting, and now you have the local experts, Mistral, Qwen, that live inside your terminal and iterate at the speed of thought.
And for developers, that speed, that throughput, is often more valuable than raw IQ. A model that can try 10 solutions in 10 seconds is so much better than a genius model that takes a minute to give you one answer.
It feels like we're approaching a tipping point where model size is becoming an obsolete metric. It's not about how big the brain is, it's about how fast it can verify its own work.
That is the lesson of Qwen 3. The future isn't a trillion parameters. The future is a few billion parameters, a compiler, and a really, really tight feedback loop.
What a fascinating week in the history of code. Whether you are Team Cloud or Team Local, the tools just got a whole lot sharper. Thanks for helping us break this all down.
My pleasure.
And to everyone listening, check the show notes for links to the Qwen technical paper if you really want to geek out on the MOE details. We will see you in the next deep dive.